Special relativity has a reputation for being difficult. Warped space-time, paradoxes, equations that seem to come from nowhere. People spend years trying to understand it. But here is the thing. You only need one idea. One. And once you have it, everything else follows as pure logic. Here it is. The speed of light is the same for everyone. Always. No matter how fast you are moving, no matter which direction, light always passes you at approximately 300,000 kilometers per second. Every single time. That sounds simple. It is not. It breaks something deep in your intuition. Imagine you are standing still and a car drives past you at 60 kilometers per hour. Now imagine you run after it at 20 kilometers per hour. From your perspective, the car is now only moving at 40 kilometers per hour relative to you. That is how speeds have always worked. You subtract them. Now replace the car with a beam of light. You are standing still. Light passes you at sea. You accelerate your spaceship to half the speed of light and fly toward another beam of light. Logic says it should come at you at 1.5 times c. It does not. It still comes at you at exactly c. Every measurement, every experiment, every time, the speed of light does not add. It does not subtract. It is just c, always. Einstein did not discover this from theory. Experiments had already shown it. He was the one who took it seriously as a fundamental fact and asked, what would the universe have to look like for this to be true? The answer is special relativity. Now let us build the key consequence together. We are going to use a clock, not a normal clock, a light clock. Imagine two mirrors, one above the other, with a pulse of light bouncing between them. Every time the light hits the bottom mirror, that is one tick. Simple, precise, and it works entirely on light. You are sitting next to this clock on a spaceship. The light goes straight up, hits the top mirror, bounces straight back down. Tick, up, down, tick. From your perspective, the light travels the same distance every tick. The clock runs at a perfectly steady rate. Now imagine I am watching your spaceship fly past me at a very high speed. I can see through the walls of your ship. I watch your light clock. Here is what I see. The light does not go straight up and down. Because your ship is moving sideways, the light has to travel diagonally to hit the mirrors. It goes up and across, bounces, comes back down, and across. It traces a zigzag path, a longer path. But here is the critical part. Remember our one rule. The speed of light is always c. No exceptions. Now look at the equation. Speed equals distance divided by time. Speed is locked. Distance just got longer. Something has to give. And the only thing left in that equation is time. So time stretches. Your clock ticks more slowly. Not because anything is broken, because the maths has no other choice. This is time dilation, not a trick of perception, not an illusion. Your clock is genuinely ticking more slowly because you are moving. Time itself is passing more slowly for you than for me, and the mathematics comes straight out of this picture. The path the light traces for me is the long side of a right triangle. Your distance between mirrors is one short side. The distance your ship moved is the other. Pythagoras. That is all you need. From that triangle, you get the Lorentz factor, 1 divided by the square root of 1 minus v squared over c squared. At 90% of the speed of light, time runs about 2.5 times slower. At 99%, about 7 times slower. As you approach c, time nearly stops. This is not science fiction. We have measured it. Subatomic particles called muons are created in the upper atmosphere when cosmic rays hit it. By rights, they should decay before reaching the ground. They are short-lived, but they arrive at the surface in huge numbers because at the speeds they travel, their internal clocks are running so slowly that what is a few microseconds for them is much longer for us. We have measured the time dilation directly. It matches the equation exactly. All of this comes from one thing. Light is always c. Length contraction. The twin paradox. Why nothing can travel faster than light. Why mass and energy are the same thing. All of it flows from that one rule, applied with pure logic. Einstein was 26 years old when he published this. He did not have access to any experiment that others did not. He just took one strange fact about the universe seriously and followed it wherever it led.